Welcome to the presentation of my MSP432P project. This project is part of the elective subject Microcontroller Technology by Professor Andreas Terstege in the degree course Angewandte Mathematik und Informatik, which means translated Applied Mathematics and Computer Science, at the Fachhochschule Aachen. In this project, I programmed an implementation of the game HEX in C++ for the microcontroller with an extension. The MSP432P is a microcontroller by Texas Instruments, and the Educational Booster Pack MK2 is an extension for this microcontroller, also by Texas Instruments. On the Educational Booster Pack MK2, I use the 128 by 128 liquid crystal display, the joystick and the two buttons. But first, let's take a look at the game HEX. The aim of the game is to connect the opposite sides of a parallelogram. The parallelogram is made of hexagons. There are two players taking turn claiming hexagons. Only 3 hexagons can be claimed, and in this case the players are red and blue, and red always claims first. The game ends when two sides are connected and a tie is impossible. To compensate for the advantage of the first claim, there's a change rule. This rule allows the second player, the blue one, to choose after the first red move whether to continue as blue or switch with the red player. When the microcontroller starts, you get into the menu. But if you're new to the game, I recommend you to press the S2 button to get to the Help menu. Here you can find some general information on the controls and the game. By clicking on the S1 button, you always get back to the menu. Here we can adjust the settings concerning game size, change rule and player mode. As size, you can choose a game board of 2x2 up to 11x11 hexagons. For the player modes, you can either choose to play yourself or you can choose an easy or random AI. Now let's start a new game. As red, we claim first. Then the AI decides to continue as blue and claims its first field. The colors in the upper right corner indicate the current player. If both colors are activated, the change rule needs to be decided. Back to the menu, we can see the Continue button is now activated. Here we can go back to the current game. As last setting, we can also adjust the brightness of the display. My basic goal was to write the code in such a way that it has a high reusability, is as hardware independent as possible, and is easy to adapt. Therefore, I decided on a model view controller structure, whose interrupt handling mainly takes place in derived handler classes. I use derived classes from a self-written graphical data object class to be as flexible as possible when designing the optics. At the beginning of the project, the memory management and the general performance were major challenges that could be overcome through consistent adjustments and optimizations. Thanks for watching und auf Wiedersehen.